All right. Thank you for coming after lunch. How was lunch? Did everybody have a good meal? Yeah? Awesome. Before I start, I have a few questions. I'm assuming all of you are PHP developers, or most of you are PHP developers. But I think there's two main different kinds of PHP developers, those who work on APIs and those who work on back-end generated pages, like using Twig or Blade or PHP just to generate HTMLs. Who works on an API using PHP? Okay. Who does the other thing? Well, I still see a lot of hands, and that's good, because I'm going to talk about both of those, and I'm going to make a little bit of a distinction between both of those different kind of web apps or web pages as you have. And I'm going to talk about how JSON Web Tokens might be used with those kinds of backends, APIs, or just all the logic on the backend. But before I start, I have to admit, I am not a PHP developer. Ooh, indeed. If you're really disgusted by me right now, you can just leave the room and I will not be mad at you. But if you stay around, I will be happy as well. So what am I? I am a developer advocate engineer at Auth0. And a developer advocate means basically that I try to talk with developer communities, try to listen to what they want and what they need and what's living in those communities. And then we just slapped engineer on top of that because I also know how to write code. And then Auth0 is an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow, so you can actually focus on building your own products, your web apps or your apps or whatever you want. I'm also a Google developer expert, which means not that much. I organize a meetup in Belgium and one in London. The one in Belgium is front-end related. The one in London is identity and security. So if you're ever in Belgium or in London, please join us. And you can find me on the internet as Sambego. Okay, I have cat stickers. Woo! I heard a woo somewhere. Thank you. If you would like to have a cat sticker, send me a picture of your cat, your dog. We're in Spain, so maybe you have a bull somewhere. Just send me a picture of an animal, and I'll give you some stickers after my talk. But let's get started. I'm going to be talking about three different things today. Traditional authentication, that's the kind of PHP apps or other apps, doesn't have to be PHP, which I talked about, where you generate the pages, the HTML on the back end, and then just push it to the browser, and most of the logic is being handled on the back end. I'm going to be talking about what a token is, and we're going to look at token-based authentication with APIs and how to use them with single-page applications, or other applications if you would like to, doesn't really matter. So traditional application, all the logic is handled on the back end. We just push HTML pages to the browser renders them, and when we click on the link or on a button, usually we have a page refresh, right? Sounds familiar. So we have a user, a browser, and a server, a backend, doesn't matter what it is. And the user just requests pages until it hits, or he or she hits a page that is protected, which means that the user will have to log in to access that page or have to log in to do a certain action on that page. So when that happens, we usually ask the user to enter their credentials, username, password. And if these credentials match, if we have them somewhere in the database and they are OK, we just send the page to the browser and the browser will render this. This is a pretty standard scenario. But because we don't want our users to log in with every page they request, we usually send a cookie as well. This is usually a session cookie with a session ID, just to remember that we have a session going on that the user has authenticated before and was successful in doing so. And this cookie is being stored by the browser, and every next request we do to a protected resource or a protected page, we send that cookie. If the session is still valid, we just send the page back. Pretty standard. Nothing new. If so, cool stuff anyway. And that's basically what I consider a traditional web app. Now, there's a few differences between traditional web apps, the one we just saw, and single-page applications. The first one, a traditional web app or architecture is usually one-to-one. You have one backend system. This can be 10 million servers. Doesn't matter, but it's usually one system and one app which is generated by the browser, is generated on the backend and then rendered by the browser. Well, a single-page architecture could look something like this. You have your app with a lot of logic in the browser, sometimes living on their own domain, and then you have a bunch of microservices or APIs or whatever you want to use with that app, like a main API, something to handle your users or authentication or identity data, maybe a payment API, maybe some external ones to get the weather or to get traffic or whatever. So you can have a bunch of APIs that are all consumed by this one web app. And sometimes you have something like this, a mobile app. a web app, a desktop app, and they all want to connect to the same API. Who's working on a product that has something like this at the moment? I see some hands. I think this is getting more common and common. And the funny thing is, in our previous example with the traditional web app, we used a cookie to remember the session, to remember the state, to remember that a user has authenticated. But cookies are something that is only being used on the web. So it would be nice if we had a more or less similar way to remember state, session for all of these apps, and not only cookie for web app, something else for mobile app, and something else for a desktop app. So what are some of the problems with the traditional cookie-based approach? Cookies don't like CORS. Who likes CORS? I see one guy lying in the back. Nobody likes CORS. The thing is, when you run into a CORS problem, what you do, you go to Google, you type in, I have a CORS problem, open Stack Overflow, and there's this one answer which answers everybody's question, because there's only one person in the world who knows how CORS works. So cookies don't like CORS because a cookie is usually issued to a certain domain. Usually it's always issued to a certain domain. Cookies also require state because in this cookie, most of the times, we will put a session ID, which is just a pointer to some database record which contains some more information like an expiry date or some other things you might find relevant for that session. And with these modern APIs these days, we would like to have them stateless. So it would be nice if we could have this session, this authentication, as stateless as well. And cookies don't flow. You cannot just pass along a cookie generated by a certain API or a certain backend to another backend because that's not how cookies are supposed to work. So what is the solution? Maybe it's token-based authentication. We'll see a bit later in this talk. But before we talk about token-based authentication, we first have to see what a token is. To me, a token is a unique identifier representing something, and this can be anything. As long as I can take a token and get some useful meaning out of it, to me, that's useful as a token. And there's a bunch of different kind of tokens. Who's ever used an access token before? I see almost all hands. Perfect. An ID token? A bit less hands. We're going to see what these are later. This is just a poll. Who's used a refresh token? Who likes refresh tokens? Depends on your use case. They're still perfectly fine in some use cases. They're not always fine because of security issues. But they are a very common kind of token. And they're often an opaque string in the form of a UUID, something unique, a database ID, but they don't have any meaning except that that database ID is somewhere in your database and you have stored some other data with that. But it doesn't have to be. If you're using SAML, for example, it's a bunch of XML. And this bunch of XML is also a valid token in the SAML framework. And it can also be a JSON Web Token. Now, as the title or the name suggests, JSON Web Token is a bunch of JSON. And at Auth0, we use them as much as possible for the only reason that we like them and we think they're very useful. And this is a JSON Web Token. Who's ever seen a JSON Web Token before? Who's ever noticed that it's made out of 3 different parts? I see a little bit less hands. That's awesome because that means that you will be learning something new today. And like I mentioned, a JSON Web Token is made out of 3 different parts. There's 2 dots in a JSON Web Token, always 2 dots, which will separate the 3 different parts. The first one in red is the header. The main big one in purple is the payload. And the bottom one is a signature. So the header, what is the header? Basically, it's just a JSON object which we base64 encoded. So if we decode it, we get something like this. The header just tells us a bit more about what the token is, which algorithm has been used to sign this token to verify its validity, and what it is, the type. I'm a JSON Web Token. It just says to you right there in the header. The same thing goes for the payload. Again, it's just a JSON object in the form of base64. If you decode it, you might get something like this. And it can contain a whole bunch of things. As long as it's valid JSON, you can put it in your payload of a JSON Web Token. So it can contain the subject, usually that's your user ID, maybe your given name or your family name. And it can also contain the date that it has been issued at and the date that it will expire. And that's something very useful to know. A JSON Web Token can contain its own expiry date. So no need to store that somewhere in a database and look for that expiry date every time you want to validate that token. You just look inside of the payload and see when the token will expire. And there's a bunch of different claims. The first set of claims, and the claim is a key value pair in the JSON Web Token, are reserved claims. And reserved claims are basically the ones that have been specified by the JSON Web Token spec, like subject, issuer, which authorization server issued this token, the issue that date, the expiry date. There's a few more, but these are all specified by the spec of the JSON Web Token. The second one are public claims. And these are claims that are used often with APIs, things like family name, giving name, preferred username, but they're not standardized by the JSON Web Token spec. So we live in a world where there's a lot of web development going on. There's a lot of people thinking about standards. So they made another standard. It's a loose standard. It's made by IANA, and it's basically just a list of often used claims. So you have a bit more API interoperability. So for example, you use given name instead of first name. You use family name instead of last name. And if we all would use the same names or the same claim names, it would make using different APIs a bit more convenient. And then the last type of claims are private claims. And this is anything that is of use to you, the one who is using this JSON Web Token or is going to consume this JSON Web Token. As long as it's valid JSON, you can put it in there. Doesn't matter. It can be a string, can be a Boolean, can be anything. But since it's just a base64 encoded JSON object, please don't put sensitive data in it, because we can all go to base64encoder.com or whatever, paste it in and see what's inside of it. So keep in mind that it's just base64, and don't put sensitive data inside of the payload. Also, since we're going to be sending this token with every request we are going to do, at least every request to a protected resource, try to keep the payload as small, because the more data you put in that JSON, the bigger your base64 string will be, so the bigger your header, your token in the header with every request will be. So try to keep it as small as possible, and only put in relevant data that you have use for when using this token. And then the last part is a signature. And it can be something like this. You take a signing algorithm, this one is HMAX, and you take the base64 of your header, take the base64 of your payload, some secret, because this algorithm uses a shared secret to create the signature and to validate it. And then you run all of it through that signing algorithm, which means that if you change something in the header or you change something in the payload, the signature is also going to change. And this means that if people would try to tamper with the payload, somebody tries to intercept your token when using it and try to change the payload, the signature would not match, because the secret is only something that you know and maybe the entity that wants to validate the token. JSON Web Tokens can be verified with this signature. And usually your secret is, of course, a bit more secure. It's not just secret. So if we would do this in practice, we have some JSON right here. We take a base64. We have another piece of JSON, which is our payload. So if we do PHP and then Barcelona, that's not Barcelona. Was a nice name as well, though. And we take the base64 of this, and then take both of those base64s and run it to a signing algorithm which has secret as this secret, and paste them all together. We get a JSON Web Token. Now, if I were to copy this one and paste it in, this is JSONWebToken.io, which basically lets you debug JSON Web Tokens or create them if you want to. We can see that we have in our payload on the right PHP Barcelona. So by just creating those two base64 encodings and signing it, we just created a JSON Web Token. Of course, you will all probably use a library for this because there's a bunch of them out there. So some real-world examples. An access token. I think most of you just raised your hand earlier when I asked who's ever used an access token before. In the form of a JSON Web Token, it could be something like this. Now, it's important to know that an access token is something that is going to be consumed, used by an API. So it will contain data that is useful to an API. It's going to contain who issued it. This is my authorization server, or Auth0 in my case. Which user it's issued for, my user ID. Which audience, and this is basically just a list of all the APIs that can use this token. If we try to use this token with an API that's not in this list, it would probably not accept it. The issue date, expiry date, and also the scopes that I granted to the user when this token was issued. So this is all data that's related to using an API. The same thing for an ID token. An ID token is a token that's going to be used to do something with the identity of the person that's just authenticated. So it's going to contain a bunch of information about the identity of the user that has authenticated before, so as things like the nickname, your name, which is not an email address, a picture, and then again, expiry date, issue date, and stuff like this. So all data related to the identity of the person that authenticated. Access token, used by an API. ID token, used by usually the front end to do some things with the identity of the person that authenticated. JSON Web Tokens are part of the JOSE specification. If you've never heard of this, this little term JOSE, it's not a Mexican name. It's an abbreviation of JSON Object Signing and Encryption, which is basically just a collection of different things which use JSON and do something with signing and encryption. Things like a JSON Web Token, the thing we've just been talking about. You also have a JSON Web Key, which is basically just a public key which you can share in the form of JSON. JSON Web Signature, which is more or less the bottom part of a JSON Web Token. You can sign something to ensure that it's not been tampered with. And you have JSON Web Encryption if you want to encrypt certain content on the web and then share it as JSON. Now, we've seen this little signature thingy before where we used a shared secret to sign our signature, and that's using a symmetrical algorithm. There's also a bunch of asymmetrical algorithms. These are the ones supported. I think there's even more than these. How they work, that's not important. The important thing to know is that they use a private key to generate a signature, and they use a public key to validate the signature, which means that we would like to share this public key with the people who want to validate our JSON Web Tokens. If you are building a service that wants to validate my JSON Web Tokens, you need to have access to my public keys. So if you want to share it, we use a JSON Web Key, the thing we saw before. It looks a bit like this. It's again JSON. Can be multiple, you can share multiple keys, and what it contains is just some information that's useful if you're working with public keys. If you're using OpenID Connect, you can usually find this route publicly available on your authorization server. It's just some information about the configuration of your OpenID Connect setup. And one of the links inside of that is a JWTs.json file. So if you're using OpenID Connect, there's usually a public JSON file which links all of the public keys that you can use to validate the tokens that have been used by that authorization server in this instance. So if we click on that, this is the OpenID Connect configuration. It contains a bunch of information, and one of them is the JWTs URI. And again, that's just a public key in the form of JSON. So let's make a little comparison. On the right, we have a Belgian passport, which basically says I'm a passport issued by the Kingdom of Belgium from the European Union in 4 languages, because we like to make it a bit more difficult in Belgium. And that's kind of the same thing as the header of a JSON Web Token. The header of a JSON Web Token says I'm a JSON Web Token, and the person or the machine that created me used this algorithm to sign my signature. So if you want to validate me, please use this signature. The same as I'm a passport created by the Kingdom of Belgium. Now, if you open a passport, my passport will contain my name, my nationality, my passport number, and also my expiry date. And that's more or less the same thing as the claims inside of a JSON Web Token. It can contain a lot of things. If you're using an ID token, it contains some data which are useful for the identity of a user. If it's an access token, it's some data which is giving you access to an API. And a passport usually has a few features to distinguish that it's a real passport, like a fingerprint or some holograms or stuff like that. And the JSON Web Token has a signature which you can use to validate the content in the JSON Web Token. So let's see it in action. I have this little web app which has 2 main buttons. The first one will show me a random dog picture, because who doesn't like dogs? You can leave the room if you don't. And the second one will show me a cat picture. But if you know cats, you know that dogs are like, yes, please show pictures of me to everybody. Well, if you have a cat, they will be like, please don't take a picture of me. And if you take a picture, please ask them to verify that they are allowed to see my picture. So to show these cat pictures, we first need to log in. So when I click on the login button, we will quickly log in. And once this has been done, we get a failed demo. But that's not a problem because I have a video of it working. Always come prepared. So let's just try that and not try to debug what was going on. So again, we click on the show me a dog picture, and it's going to show you dog pictures. And then for the moment we click on show me a cat, it gives you the error. We try to log in, so we click on the login button, go through the whole login procedure again. Click on the right email, and we just logged in. And let me pause for a second. From the moment that we logged in, we got back a few tokens, an access token and an ID token. And we can do different things with those. The ID token has been used in this example to show my avatar and my name on the top. So no need to do an extra request to get some information about who logged in. We just got it back in this ID token. And we got back an access token, which we can then use to get the actual cat pictures. So now when we click on show me a cat, we do a request to this cat endpoint with the JSON Web Token, and we can see the cat pictures. This is my actual cat, which I'm very proud of. So if we look at this from an API perspective, I have this very small example. We have 3 endpoints, one to authenticate with some big one password. Please use a better password. So if we do this, we get back a JSON Web Token. We have a second route, which will just send us random dog pictures. And then we have a third route, which will send us a cat picture if we are allowed to see it. So to see cat pictures, we'll just send along the JSON Web Token we just got as a bearer token. And ta-da, invalid signature. I forgot? Okay. Thank you. So I forgot the last E. Huh. But maybe this is not a bad accident because we already can see one of the first actions that, or errors that you can get if something goes wrong with a JSON Web Token. That is, as soon as the signature doesn't match, in this case it doesn't match because it's not complete, you can already reject the token because it means that probably somebody has tried to tamper with the payload inside of the token. So if we paste in the correct token and try it again, we get a cat picture. So ta-da! But we just had this accident which showed us that we can already check for an invalid signature, but we can do other things with JSON Web Tokens as well. If you would paste in a JSON Web Token which has an expiry date which is in the past, which means that the JSON Web Token has expired, we can already see from just looking inside of this token that we don't want to accept it anymore. We don't have to do an extra request, check in our database if it's still a valid session. It just tells you right in the token, I'm expired because the expiry date has been in the past. So by just looking inside of the token and by just checking the signature, you can already rule out a lot of use cases in which you don't want to accept a JSON Web Token. If you want to know more about JSON Web Tokens, you can go to JWT.io. It's this little website I used before to look inside this token we created earlier. It contains a bunch of libraries, also PHP libraries, which help you work with JSON Web Tokens, and it gives you a lot of information as well. We also issued or created a JSON Web Token handbook, which goes very, very in-depth into JSON Web Tokens and all of the things that can go wrong with it, all of the vulnerabilities that you have to be aware of if you're using it, and you build everything from scratch. So if you're interested in that, follow that link. So are there any downsides to JSON Web Tokens? There are. The invalidation of tokens is a bit harder because a JSON Web Token contains all of the information you need to validate it inside of it, the signature, the expiry date, the audience, some other things. As soon as you issue the token, it's valid until it expires. So if you want to invalidate an issued token, you kind of have to work with a blacklist or a whitelist or something like this. And if you leak your secret or your private keys, that can be a real headache. That's why we call them secrets and private keys, not public stuff. So try to keep all of that very, very private. And again, don't put any sensitive data in your JSON Web Token because it's just base 64. On to the last part, token-based authentication. We have the same use case as in the beginning, user browser and something in the back. and the user tries to access pages until it runs into a page that has been protected and for which it needs to authenticate, sends username and passwords, and if that matches, instead of a cookie, we get back an access token because in this instance we're trying to use an API. And we save this somewhere in memory, and the next time the user wants to reach an API endpoint that is protected, we just send along the access token, and if that's a valid access token for that API endpoint, we just send the data back. So it's more or less the same as in the beginning, but instead of a session cookie, we use an access token. Who's used auth before? A lot of hands. Cool. Auth is a protocol that allows a user to grant limited access to their resources. And this is very important because people misuse auth a lot. Auth is made to grant limited access to their resources. So if you want to give somebody access to a certain resource, all of your resources or just a subset of it, you can use auth. You cannot use auth to do identity-related things. If you want to do that, or for example, if you have an app and you want to import the contacts from your Gmail, you're going to send an auth request to Gmail, which will only give back your contacts, but you will not be able to send an email on Gmail, for example. You'll only get back the data you are allowed to get back. If you want to do identity-related things, so authentication with a token-based approach, you use OpenID Connect. Who's used OpenID Connect before? I think more of you do, but you just didn't realize it because OpenID Connect was created as an identity layer for Auth 2.0. You mainly just take Auth 2.0, take all what's good in it, also all what's bad in it, but take all of it and just put an identity layer on top, which means that you're also going to issue an ID token, which you can use to work with the identity of the person that authenticated. For example, logging in with Google, instead of just requesting access to all of the contacts of your Google account, you're going to log in with Google. And you can also request access to things if you'd like to, but we're also going to request access to the identity Google has of us. So in this example, I've split my authorization server from the rest of my APIs. Same example, we send our user credentials, and actually we're going to do we're going to move to my authorization server for a while and then redirect back because you don't want to enter your user credentials in some place that you didn't give them to in the first place. So if you want to log in with Google, you're going to be redirected to accounts@google.com. It doesn't matter if you're on Gmail, on Google, on what's the video platform? YouTube, or any other website that uses login with Google. If you want to log in with them, you're going to be redirected to accounts@google.com, do all of it there, and then get redirected back to your app. So we do that, and if everything went well, we get back our access token. But we can get more back. We can get back an ID token as well, access token, and a refresh token. Now, I'm not going to talk about refresh tokens yet, but we've seen what an access token and an ID token is. We save them somewhere in memory, and then whenever we need to use them, we just use them. But I've mentioned a few times that we save them in memory, and that's very important. You should never save tokens somewhere persistently, not on local storage, not in session storage, not in IndexDB, not in just regular cookies, nowhere persistent. Because if you're vulnerable to cross-site scripting, anybody can just steal these cookies and just impersonate you, the user, and do things like steal all your money in your bank account. So we are trying to mitigate that risk, and we just save the token somewhere in memory, which means that the user will have to log in with every visit because we don't save these tokens somewhere persistently. There's some ways around that. So if we take the same login flow, we get back our tokens, and together with those tokens, we get back a cookie. So we're back to the beginning. We save those tokens in memory and save the cookie somewhere in the browser. And with each next visit, so if we refresh the page or the user goes away and comes back to our page, we're going to take that cookie, usually in an iframe, do a silent request to your authorization server with that cookie, which contains a session ID, and if that's still valid, we just get the tokens back from the authentication or authorization server, and then we can use them again like we want. So basically, on Bootstrap of your single page application, you're going to request for those tokens as soon as the page loads, and usually that goes quite fast, so the user doesn't notice it, but you request new tokens over and over and over again, just so you don't have to save them somewhere persistently. And this has the added benefit that you can also rotate them, so invalidate the previously issued ones and issue new ones if you want to. And then you can just use your access token to do whatever you want to do. This was, however, using the implicit flow of auth. There's a few vulnerabilities with them: insufficient redirect URI validation, credential leakage, browser history, and token injection. You can mitigate most of them, so you can enforce a strict match between the redirect URI and the one you probably registered when you registered an auth client with a certain service. You can use the referrer policy header to mitigate the credential leakage by referrer header. And you might be able to do form posts instead of redirects to get your tokens back. But not all of it is as secure as we would like to with modern-day single-page applications. So the IETF, the Internet Engineering Task Force, published a new best practices document, which basically says, you can find more about it here or here, but I'll share the slides later, which basically says that instead of using the implicit flow, you should try to use the authorization code with proof key for code exchange flow, PKCE for short, which is a bit more secure, a bit more complicated. Looks a bit like this. So when the user wants to log in, we redirect to our authorization server. The user just logs in, and we send along a code challenge as well. The authorization server will not send back a token directly, which means that in our browser history, there will not be that token. It will send back a code challenge or a code. We will then take that code, do some things with it, and issue a code verifier. And then by using that code verifier and the initial code we send along the code challenge in the first step, we can basically verify that the same user has initiated and ended the process of requesting these tokens. We don't have referral headers anymore, and we don't have our token end up in our browser history. So it mitigates a lot of those risks, and it's a bit more secure in general. It's a bit more complicated, but most libraries these days have added or are adding support, us as well. And in the end, you just get your tokens back. So a note about access tokens as JSON Web Tokens. OAuth and OpenID Connect do not specify what format an access token needs to be. So if you want to use a UUID, that's perfectly fine. If you want to use a JSON Web Token, that's perfectly fine. If you want to go exotic and do something else, that's perfectly fine as long as you know how to handle those tokens. But there is, however, an IETF draft to standardize at least how to use JSON Web Tokens in the form of an access token, or access tokens in the form of a JSON Web Token. And I just went back to my... and then if you would go to the spec, you can see that there is a JSON Web Token on top, which looks pretty similar to the ones we've seen before. The only difference really is the type is now access token plus JSON Web Token instead of just JSON Web Token. And this draft, or this spec, it's a draft of a spec, just kind of standardize which claims needs to be in a JSON Web Token in order for it to be a good access token. But that's still a work in process, so you progress, so you can just do whatever you want. You can use whatever kind of token you want for an access token. ID tokens, however, are always going to be JSON Web Tokens. Standardized by this, like this in the OIDC spec, the OpenID Connect spec, you cannot create an ID token that is not a JSON Web Token, or you're not following the spec. And then, lastly, a note about refresh tokens and single-page applications. Using refresh tokens in the front end should be avoided unless a system of refresh token rotation or sender constraints is in place. And this is something very important because we've been using refresh tokens on the front end with single-page applications for a long time. But because all of the logic is handled on the front end in JavaScript, sometimes these tokens are stored somewhere persistently, like in local storage. As soon as your refresh tokens get leaked, you're in a big problem because these refresh tokens can issue new access tokens. And we don't want that. So unless you rotate your refresh tokens, which means that as soon as a refresh token has been used, it becomes invalid automatically, and you'll issue a new refresh token. And it can also do this just on a time-based constraint as well. So unless you do that, or you have something which is called sender constraint in place, don't use them. And sender constraint is something that sounds very, very nice. It means that you can tie a sender to the JSON Web Token, but that's technically not possible yet. There's some people thinking about how to do this on the web, but there's no practical implementation of how to do this yet. So unless you do refresh token rotation, try to avoid refresh tokens, at least with single-page applications in the front end for now. So who thinks that this approach solves CORS, or the issues we had with CORS? I see very few hands. A few brave ones, and I think you are right, the brave ones, because a JSON Web Token is not issued to a certain origin, to a certain domain. As long as you know how to validate the signature, as long as you know how to look inside of a token to see if it's still valid or it has expired, anybody or any service can use that token, as long as you know how to validate it. So if this is your origin, your domain, or this is a third party, it doesn't really matter. You can send them the token. They will know how to validate it. They will have access to your secret or your public keys, and they can use it. So it does solve, of course, in a way. Who thinks that this approach solves the flow issue, passing tokens from one service to another? See some hands? A bit more? I think it does, because, again, it's not tied to a certain service, not tied to a certain origin, not tied to anything. As long as you know how to use these tokens, you can just pass them along if the other service also knows how to use these tokens. In theory, you're not going to do this. You're going to exchange the tokens with a token endpoint and get some new ones for the next service. But in theory, you could just pass them along as well, as long as they have access to your public keys or your secret. And who thinks that this approach solves keeping state? I see some hands as well. And you might be right, and in theory it does, because a JSON Web Token contains all of the information you need to validate inside of it. But if you want to do things like keeping a blacklist or a whitelist to invalidate tokens, you're keeping state again. If you want to go to the very complicated example I gave in the end, where you also issue a cookie, a session cookie, and then get the new tokens every time on Bootstrap of your front-end app, you will kind of need to keep some state. So in theory it does, but because there's some clever people trying to misuse them or misuse any system, you end up with a little bit of state anyway. So let's summarize. Using session cookies is hard with single-page applications. Most of the times, if all of your systems run on the same domain, same origin, you don't have requests to external systems, you can still use a cookie-based approach because you will not end up with CORS. But with most modern applications, that's not the case anymore, so it can be hard to use cookies in those instances. Stateless authentication is possible, asterisks, blacklists, whitelists, keeping some session anyway to use a cookie to get new tokens. That's some state. And JSON Web Tokens consist out of 3 different parts. The header, which gives you some information about the token itself, which algorithm has been used to sign it. The payload, which contains the actual information we want to use with this token. And the signature, which lets us validate that nothing has changed since we issued the token with the payload or the header. If you want to know more, JSONWebToken.io. We also have a website, webauthn.me, which is about the new web authentication API. If you're interested in this, come talk to me because I can go on for hours about that one. If you want to know more about why the IETF issued this best practices document to step away from the implicit flow and go to the PXE flow, we have a blog post explaining it in detail, and our blog is full of other things. By the way, just because they published this best practices document doesn't mean that you all have to start rewriting your apps, because most of the libraries you use, most of the people who work on authentication systems know about these risks for years, and they've built in ways to mitigate all of the risks that there are. But if you're starting from scratch, maybe you can look into using the PXE flow instead, just because it's a bit more secure. If you want to see these slides again, jwt.sambego.tech. I'll give you a second so you can take a picture, but I'll tweet about them later as well if you're too lazy to take a picture. Okay. Thank you very much.
Yeah, we've got some questions as well. Some people are interested in best practices to actually store the JSON Web Token on the browser, like if you have any extra
Yeah,
insights.
so I mentioned this briefly, and it's kind of complicated, so try to avoid storing them on local storage, IndexedDB, anything persistent, unless you might be able to use a HTTP-only cookie. That means that you don't have CORS issues. That's okay. Otherwise, keep them in memory and request new tokens each time again and again and again, just so people cannot steal them through XSS or not as easily.
Then people are asking about recommendations for signing, either a secret key or public-private exchange or extra thoughts, I guess.
Yeah, they both have their, if you use a secret to sign and verify it, it's a bit faster than a private key and a public key. But private and public key approach is a bit more secure, so it kind of adds up with, depends on what you want to do with it or how secure you want to be.
And then there are a bunch of questions that I guess we can group them kind of. So it's all about, logging out, revoking, best practices, time more or less, all this sort of the logout kind of thing and revoking tokens?
So yeah, logout is very tricky with JSON Web Tokens because they contain their data inside of it. The thing you could do is put them on a blacklist.
Keep it low.
or put them on a special logout list. Usually when you log out from a single page application, you just delete these tokens from memory.
Just delete them.
So they don't exist anymore, at least in the front end, and you just do a request to your API telling you that that token is not valid anymore, so put it on a blacklist. But there's a whole bunch of different ways that you can tackle this, and this all depends on your use cases. But if you want to know more, just come talk to me.
And a final one, that one's related to your company more than yourself or the talk. They're asking about, there's a blockchain indie project related to authentication. If you heard about it and you have plans to integrate that in
As far as I know, we don't do blockchain.
Okay.
Nothing.
And not sure if there are any, oh, sorry. And if there are any extra questions in the room? No? Don't see any hands. Okay, well then, thank you very much.
Thank you.
Thanks a lot.